This is my Part C submission. The original lab environment for measuring the speed of light involved a setup that allowed for the time difference between two light waves to be directly measured. The original lab equipment used to measure the speed of light involved a tooth wheel and a reflective mirror. The original experimental procedures for measuring the speed of light involved a series of clever, innovative methods. Galileo attempted to measure the speed of light by timing the intervals between the flashes of two lamps held by assistants on different hilltops. The initial hurdles in the speed of light included the need for precise measurements and the understanding of its nature as both a wave and a particle. Traveling at the speed of light presents several safety issues due to the extreme conditions and challenges involved, things like energy requirement, time dilation, and physical stress. Examples of equipment issues are time measurement errors, which can lead to incorrect speed calculations, beam splitter design, which affects the time difference between two light waves, and detector sensitivity can affect the detection of light waves, information processing issues, or quantum computing. The original goals of scientists in the quest for the speed of light were to understand the nature of light and its properties. The discovery of the speed of light was accidental. The speed of light was discovered by Ole Reaumur in 1676. He was expected to benefit from its discovery in the following ways: for navigation, astronomy, and scientific method. There were immediate benefits in the field of astronomy and navigation. It provided a new method for determining longitude, which was crucial for navigation and mapping. Some immediate advancements in the original field of the speed of light include development of new methods for measuring light's speed and the establishment of a new accepted value for the speed of light in vacuum. In other fields, the speed of light remains constant in all frames of reference, a principle that has led to the formulation of special relativity, which predicts the existence of waves in electromagnetic fields and their speed. In brand new fields, the speed of light has led to the new discovery like relativity, quantum mechanics, and electromagnetism. The modern lab environment for measuring the speed of light typically involves a setup similar to of Lefoucauld's design, which deviated by about 0.6% from the current accepted value. Some modern lab equipment is lasers, beam splitter, and oscilloscope. The modern experimental procedures for measuring the speed of light involve using advanced technology and precise measurements to achieve high accuracy. Some modern advancements of the speed of light involve special relativity, GPS technology, and astronomy. Surge protector devices are essential for protecting electronic currents and equipment from high voltages, surge currents induced by lightning, and other forms of transits. The modern information gathering of the speed of light involves a combination of theoretical and experimental approaches. Some of the modern information processing developments are quantum photonic chips, nanoscale photonics, and photonic computing. Some modern benefits. Understanding relativity is one of the modern benefits of research of the speed of light. The consistency of the speed of light in a vacuum has led to the development of special relativity, which describes the behavior of matter and energy and the structures of space-time. And some other fields that benefit from this research include medicine, technology, and engineering. Some examples of technology that spawned is global positioning systems, optical fibers, and lasers. Future goals. Some potential future goals of scientists are things like non-reciprocal control of light, sunbeam missions, warp drive technology. Some potential benefits to come involving the speed of light are things like enhanced communication, advanced navigation systems, and precise engineering.
Hello, my name is Trace Anderson, and this is my Part C group project recording. An original experiment was by Ole Reaumur, where he studied Jupiter's moons in 1670, and from that experiment he estimated the speed of light. The location was a Paris observatory. His equipment was a telescope, and the process was he watched moons and recorded times for them to have eclipses. Some difficulties was that a clear sky was needed to see the moons through the telescope. Timing errors, because keeping time was not as good way back in the day as it is now. And reduced sleep from staying up late. And eye fatigue from looking in a telescope. His original goal was to predict Jupiter's moon low, and while doing that, he saw that the eclipses were happening at different times, depending on how close the Earth was to Jupiter. So as a byproduct, he found out that light has a speed and it's not just instant. Astronomers and people who used longitude and navigation were expected to benefit from this. Some benefits of this were that it proved that light has a speed and is an instant, and it inspired other scientists to think about it. A more modern experiment is something called the rotating optical cavity experiment done in 2010, where the location was in a thermally stabilized vacuum chamber. The equipment was a frequency stabilized laser and a precision air bearing turntable. And the process was they locked these lasers in a vacuum chamber and recorded two continuously rotating laser cavities. There seems to be much more advanced equipment and processes nowadays. There are strict safety protocols to protect not only people, but expensive equipment that could cost millions of dollars. Examples of safety protocols would be grounding so that electrical hazards, somebody doesn't get electrocuted. Some new ways of recording nowadays is remote recording devices, so they don't have to actually be in there with the equipment. And also, of course, computers are used to gather information and process information. Some benefits were that it confirmed that light speed is the same in all directions. Other fields expected to benefit are metrology, which is like precision instruments. Some spawned technology was used in atomic clocks and GPS calibration. Some future goals for scientists related to the speed of light is to see how it behaves in extreme environments such as near black holes. Potential benefits to come could be improved distance measurements in space navigation.